You want to talk about origins? We are diving right into it today. Creationism and how it lines up with, well, science. We've got a lot to get through. Young Earth creationism, the Big Bang, even this RNA world idea, like before DNA. And I got to say, the passion on both sides of this, it's really something. We're going to try to untangle it all, see what we find. So when we say creationism, what are we actually talking about here?
Basically, it's the idea that the universe, life on Earth, it was all created by, a supernatural being. One of the sources we have even defines it as the belief that the creation story of Genesis is the literal truth about how the world came into being.
Okay, so Genesis, literal interpretation, but something tells me it's not quite that simple. Like, there's going to be more to it than that, right?
You're right. It's not just one thing. It's a whole spectrum. You've got young Earth creationists, for example. They believe the Earth is what, like 6,000, 10,000 years old? And those 6 days of creation, I mean, literally 6 days.
Right, 6 days, I gotcha. But there are other views too, right? Like old Earth creationism.
Exactly. Old Earth creationism accepts the science, billions of years. But they still believe God was in control, guiding everything.
Okay, so how do they reconcile that? Billions of years, but also a creator God.
Well, they look at those days in Genesis as longer periods, not 24 hours, more like vast epochs of time. So God set things in motion.
Interesting. That actually makes me think of intelligent design. Is that kind of in the same ballpark?
It's related. Intelligent design focuses on this idea of fine-tuning. Basically, they look at the universe and they're like, it's almost too perfect for life, don't you think? Like someone set it up that way.
Too perfect to be random, that kind of thing.
Exactly.
Yeah.
The odds of the universe where life is possible just appearing by chance, they see that as evidence for, like, an intelligent designer.
Okay, I see. Anything else we should cover on the types of creationism before we move on?
Yeah, we should at least touch on gap creationism.
Yeah.
They say there's this gap between verses 1 and 2 in Genesis, a big gap. And that gap, that's where they fit in the billions of years the Earth's been around, try to make it all fit.
A gap, huh? Interesting. Okay. Is that where, like, flood geology comes in? Always found that kind of stuff interesting.
Yeah, flood geology is big with young Earth creationism. But basically, it's looking at things like the Grand Canyon and saying, see, that's evidence of a global flood. They think those features were formed quickly, not over millions of years.
Right, which is different from the mainstream view, plate tectonics, erosion, all that stuff happening over, like, really long periods.
Yes, exactly. And that brings us to a key point. Science has a different explanation for, well, everything. How the universe began, how the Earth formed, how life started.
Right, one that's all about evidence, constantly testing and refining.
Exactly. And that's where things get really interesting, the heart of the debate, when creationism and science, kind of bump up against each other.
Because even with all the different types of creationism, science is pretty clear about some things, like how old the universe is and, the whole evolution thing.
Right. And that's where the Big Bang Theory comes in. It says the universe didn't just appear, it expanded from this incredibly hot, dense state billions of years ago.
The Big Bang, huh? It's one of those things like, I know it's a thing, but it's almost impossible to actually picture.
Oh, it's mind-blowing for sure.
Yeah.
Imagine, like, all of space, everything squeezed into something smaller than an atom.
Smaller than an atom.
And then it's not really an explosion, even though people say that. It's more like everything expanding, space itself stretching, getting bigger, and it just carries galaxies along with it.
So it's still expanding now. Like, that's what they mean by the universe expanding.
Still going. Yep. And the evidence is pretty convincing. Like, there's this thing called the cosmic microwave background radiation, which is like the leftover heat, basically, from the Big Bang. It's faint, but it's everywhere, and it matches what they predicted.
Wow. Okay, so you have this massive expansion, everything cooling down. How do we even get from there? Like stars, galaxies, and eventually, us.
Gravity. It's all about gravity, slowly pulling things together. So you've got these little differences in density after the Big Bang, and over a really, really long time, they start to clump. And the bigger those clumps get, the more gravity they have, so they pull in even more stuff.
So gravity is like this cosmic sculptor, basically.
Exactly. And eventually, these clumps get so dense, so hot, that boom, nuclear fusion starts. A star is born. And these stars, they bunch up too, forming galaxies. Just massive collections of stars all swirling around.
In our solar system, it was the same kind of thing.
Pretty much. About 4.5 billion years ago, cloud of gas and dust starts to collapse. Maybe a supernova nearby gave it a push. But as it collapses, it spins faster and faster, flattens out into a disk, and right in the center, our sun ignites.
Wow. Okay, so the sun's going, what about all that other stuff in the disk?
That's where the planets come from, asteroids too. It's called accretion, where those little bits of dust and gas, they collide and stick together over millions of years, and eventually you get planets.
So crazy. Like every atom in our bodies, it was all part of that cloud at some point.
It's pretty amazing when you think about it. And it kind of brings us to a point where, those two views we talked about, they really diverge because the science is pretty solid on the age of the universe. About 13.8 billion years based on a bunch of different things.
Which obviously, the young Earth creationists, they have a different idea about that.
Right. And it's not just the age of the universe. The whole how life began thing, that's another place where science and creationism have very different explanations.
Right. Abiogenesis, life from non-life. I've got to be honest, this is where I start to get lost. Like, how do scientists even wrap their heads around that?
It's one of the big questions, for sure. And we don't have it all figured out, but there's some really cool theories. Like the RNA world hypothesis. Remember we talked about that?
Yeah, RNA, right. Why is RNA so important?
Well, see, DNA needs proteins to replicate. But RNA, it can kind of do both. It carries genetic info, like DNA, but it can also act like an enzyme, speed up reactions. So scientists are thinking maybe RNA was the main player in early life.
So picture this, like primordial soup, right? And in this soup, you've got these RNA molecules just forming and copying themselves. And over time, they get more and more complex.
Exactly. And while we haven't quite made life from scratch in a lab yet, scientists have been able to make RNA molecules that can copy themselves. And they did it in conditions that are similar to what we think early Earth was like.
No way. That's incredible. Like a glimpse into a whole different world.
It really is. And it just goes to show how powerful the scientific method is. You observe, you come up with an idea, you test it, refine it. It's how we figure things out.
And it seems like, at least from a scientific point of view, you don't really need a supernatural creator for any of this.
Right. You don't need one. But, and this is important, just because science doesn't require a creator doesn't mean there isn't one. It just means that science hasn't found proof either way.
So there's still room for, I don't know, some kind of middle ground?
Potentially, yeah. Because while young Earth creationism is pretty much incompatible with what we know about science, other types of creationism, like old Earth creationism or theistic evolution, they try to find ways to bring those two things together, faith and scientific understanding.
So it doesn't have to be one or the other.
Right. For some people, it's about finding a way for them to both be true. Like, maybe God is the ultimate creator, right? But instead of creating everything all at once, they set the universe in motion, the Big Bang, the laws of physics, even evolution itself, and then they let it all unfold.
It's wild, isn't it? You've got these two totally different ways of looking at the same thing, like a literal, divine creation story, and then this whole scientific explanation with natural processes taking billions of years.
And it's in that space between the two. Right?
Yeah.
That's where it gets interesting, all the questions, trying to figure it out.
Totally. It actually reminds me of something we talk about a lot on this show, about like the importance of different perspectives. It's not always about, finding the right answer, but about seeing all these different sides of these big, complicated issues.
Exactly. When you're open to different ways of thinking, even if you don't agree with them, it just makes your whole view of the world bigger,
And you might even find some common ground in those differences.
Oh, for sure. Like, yeah, they disagree on the how and the when, but both creationism and science want to know why. Why is there something instead of nothing? Why does the universe seem like perfect for life? These are questions people have been asking forever.
It's like this need we all have, to find meaning, to understand where we fit in, and whether we find that through religion or science or however we find it. Just that searching is pretty amazing.
Absolutely. It's not about who's right or wrong, really. It's about realizing how much we don't know and that no one has all the answers.
So as we wrap things up, is there like one big takeaway you want to leave people with, something to think about as they, explore all this?
I think it comes down to curiosity and humility, really. Be curious about the universe, about where we come from, but also be humble. Remember that we're always learning, always discovering new things.
Well, it's a journey, not a destination. Who knows what we'll find along the way, initially. Maybe it'll change how we see things, make us appreciate the universe even more. So you want to really dig into this whole creationism versus evolution thing, huh? I get it. It's one of those topics that's easy to get stuck in that surface level back and forth and never really get into the good stuff.
Yeah, you want to really understand the core of what those arguments are really about, not just the talking points.
Exactly. And that's what we're doing here, going deep. We've got some good stuff to dig into, excerpts from the Stanford Encyclopedia of Philosophy, always a good place to start. A little context from, Wikipedia. And then to shake things up a bit, a really interesting book called Creation and the Universe looks at things through a scientific lens, which I'm always up for.
Because it really comes down to how we explain, like, the world around us, right? Are we relying on faith or science, or is there some kind of combination?
So how do we even start unpacking this?
Well, the Stanford Encyclopedia is cool because
Yeah.
it really gets into the history of the debate. And, it's interesting. It's not just about what should be taught in schools,
That's
right?
just what you usually hear about, right?
Right. But it gets way deeper than that. It's a fundamental disagreement about how we interpret the entire world around us.
Whoa, okay. So, like, choosing your lens, do you view everything through observation, evidence, like science does? Or, I don't know, the interpretations of religious texts? Man, that's kind of a big deal, right? Color is how you see everything.
Exactly. It shapes your whole worldview. And the thing is, this isn't just some abstract philosophical debate, right?
Yeah.
It plays out in the real world all the time.
Oh, for sure. I mean, you see it in those legal battles about teaching creationism in schools, which, by the way, the Stanford Encyclopedia mentions this fascinating court case from way back in 1981 in Arkansas. That's where things started to get especially interesting.
Oh, yeah, that Arkansas case was huge. It was a total turning point because that's where creationists really started framing this whole debate as naturalism versus their viewpoint.
Okay, so break that down for me. Naturalism, meaning?
So they were basically saying that science, the way it's usually practiced, operates under this assumption called naturalism, which is the idea that nature alone can explain everything. There's no need for a creator, no supernatural involvement. It's all just like natural processes.
So it's like you're either on the side of everything being explained by science or you're with them.
Yeah.
That's a pretty bold line to draw.
Oh, absolutely. And what's interesting? That whole framing, that us versus them idea, it really resonated with people.
Why do you think that is?
I think it's because it tapped into this deeper question that a lot of people have. Is science just another belief system?
Ooh, interesting. You mean like saying, I believe in science is no different than saying, I believe in, I don't know, the literal interpretation of Genesis.
Exactly. And that's where someone like Philip Johnson comes into the picture. Stanford Encyclopedia has a whole section about him. He was this Berkeley law professor who wrote this really influential book, Darwin on Trial. And his argument really threw a wrench into the whole thing.
Okay, from actual courtrooms to the court of public opinion. All right, so what did this Johnson guy bring to the table?
Well, he wasn't arguing about, the age of the earth or like literal interpretations of the Bible. He went straight for like the heart of the matter. He said this whole debate, it's not really about the science itself. It's a clash of philosophies.
So he's basically saying science is just as much a belief system as any religion.
Exactly. And for some people, that's a really compelling argument because it kind of levels the playing field. It's like, who's to say which belief is right?
Okay, I see where you're going with this, but I gotta imagine that's not the whole story, right? There's gotta be more to unpack there, right?
You hit the nail on the head.
Yeah.
Because while everyone is entitled to their own beliefs, it doesn't mean that all beliefs carry the same weight, especially when we're talking about like explaining the natural world.
So how do you weigh beliefs? Where do you even begin to do that?
That's where we get into the nitty-gritty of what science actually is, how it does its thing. I think for a lot of people, that's the part that gets lost in this whole debate.
It's more about the process than just like having the answers,
Yeah.
right?
Exactly.
Okay, so we've got these different ways of seeing the world, different ways of deciding what we believe, but how does that play out when we encounter something like a miracle? Does believing in those mean you have to just totally abandon science altogether?
Oh, man. That is the question, isn't it? One that's been, puzzled over by theologians and philosophers for centuries. And it's not exactly a simple answer.
So what are we talking? Different schools of thought on this again?
For sure. You've got some folks who say that miracles, by their very nature, are supernatural, right?
Right.
So they exist outside of what science can even really speak to.
So they might happen, but science can't really touch them because they're on a whole other level. Is that what you mean?
Right, exactly. It would be like, I don't know, using physics to explain how a dream works. It's just a different category.
Yeah.
But then you've got other folks who say, hold on a minute,
Who say what?
who say that maybe these miracles, even though they seem to, defy our current scientific understanding, maybe they're actually working through natural laws that we just haven't figured out yet.
So no need for any conflict between science and faith. It's all just a matter of time before science catches up.
In a way, yeah. It's about recognizing how much we still don't know. Like there could be entire realms of science that we haven't even dreamt of yet. Who knows what we might discover in 100 years?
Okay, that is a very cool way to look at it. But a part of me does wonder, like, if you can explain every miracle away with science, does that take away from the religious significance of it?
Oh, 100%. That's a point that's brought up a lot, actually, in the Stanford Encyclopedia. Because some people argue that by trying to find scientific explanations for these things that are supposed to be, from a power beyond our understanding, it actually kind of diminishes faith rather than supporting it.
Yeah, I get that. It's like maybe the magic trick is more impressive when you don't know how it's done, right?
Exactly. And that's what makes this whole discussion so fascinating, because it forces us to confront the limits of both scientific understanding and, like, religious belief.
This is already making my head spin. We've gone from courtrooms to now questioning the very nature of how we explain the world around us and what we choose to believe.
And it gets even more wild when we get into intelligent design, or ID.
Ooh, ID, okay, yeah. So that's got to be Michael Behe and William Dembski, right? Those are names I've definitely heard before, but I'll admit, I need a little refresher. Remind me, who are these guys and what's their deal?
They're like the heavy hitters in the ID movement.
Yeah.
And yeah, the Stanford Encyclopedia has a whole section dedicated to their arguments. Behe is the irreducible complexity guy.
Right, okay. Irreducible complexity. That definitely rings a bell. But, more than a bell ringing, what does that actually mean?
Basically, he's saying that there are certain biological systems, things in nature, that are just way too intricate, too complex to have possibly evolved gradually through, natural selection, like Darwin's whole deal.
So what kind of things are we talking about here?
His go-to example is the bacterial flagellum.
Okay, back up a little. What the heck is a flagellum?
It's basically this little, like, tail thing, a microscopic whip that some bacteria have. But the thing is, it's not just a simple tail. It's incredibly complex, with all these different parts that fit together perfectly so the bacteria can, like, swim around.
Yeah.
And Behe's argument is that if you take away even one of those parts, the whole thing just breaks, doesn't work anymore.
So it's like taking a gear out of a watch, the whole thing falls apart.
Exactly. And for Behe, that points to the work of an intelligent designer, someone who purposefully crafted each piece and put it all together in just the right way.
Okay, I will admit, as someone who can barely put together IKEA furniture, the idea of something that small and complex just coming together through random chance, yeah, it's a tough one to wrap your head around. And maybe this is getting too big picture too fast, but if we're talking about an intelligent designer putting together tiny biological machines, like, why not fix some of the simpler but deadlier problems?
You mean like genetic diseases and stuff?
Exactly. If your designer is so intelligent, why design something that's going to cause, so much suffering? It doesn't seem to track,
Yeah, you're getting at what's called the problem of evil. If there's an all-powerful, all-knowing, all-good creator, why is there so much pain and suffering in the world?
Right. So, like, how does intelligent design square that? Where do they go from there?
That's where William Dembski and his whole explanatory filter thing comes in. He tries to address this head-on.
Okay, explanatory filter. I like the sound of that, but also help me out. What does that actually mean in this context?
So imagine you have a filter, right? And you're using this filter to figure out what caused something. Dembski says there are, like, three main possibilities. Pure chance, natural law, like the laws of physics or chemistry, and then design, something being intentionally designed, right?
Okay, I'm following so far.
So if you're looking at something and it just seems way too improbable to have happened by chance alone, like winning the lottery 1,000 times in a row, and it's also too complex to be explained by any natural laws we know of, then Dembski's saying the most likely explanation is that it was designed.
So if it looks designed, it probably was. Seems kind of dot circular, doesn't it?
Yeah, a lot of people point that out. But Dembski would say his filter works.
No.
And he uses it on things like that bacterial flagellum we talked about. Too complex for chance, too intricate for our current understanding of natural processes, therefore, design.
I get his logic, I do. But I gotta say, I'm still kind of stuck on this whole suffering thing, Like, how does he make that fit with a benevolent, all-good designer?
Things get even more interesting there. Because he's basically saying that stuff, those, like you said, design flaws, they're not part of the grand design. It's just random chance errors slipping through the cracks.
So the designer gets all the credit for the good stuff, and the bad stuff is just oops. That seems a little convenient, don't you think?
I'll say, and a lot of people who study this stuff agree with you on that one. But it does highlight what a tightrope intelligent design people have to walk trying to fit this idea of a benevolent designer with, the realities of a world where there's a ton of suffering alongside all the amazing stuff.
Yeah, for sure. Okay, so we've gone from courtrooms to questioning the very nature of belief to now these huge theological questions. That's just the tip of the iceberg. But how does this all connect to, the actual universe out there, the cosmos? Because that's where I think things get even wilder.
That is a fantastic question, and it's the perfect segue into our next source, which is that book I mentioned, Creation in the Universe.
Yeah.
Because while it doesn't directly try to tackle the whole creationism versus evolution thing head
So it
on.
offers a different perspective, you're saying.
Yeah, it gives us a really fascinating way of looking at how we understand or try to understand the universe around us and how we approach the vastness of what we know and what we don't.
Okay, now you've got me even more intrigued. Tell me more about this book. How does it approach this topic?
So it's a deep dive into how planets and stars and galaxies, all that stuff, how it forms. But here's the thing. It challenges some of the traditional ideas we have about those processes, the kind of standard narratives we've been taught.
Okay, so not your typical astronomy book. Got it. So where's the tie-in to the creationism debate? How does it all connect? So we're saying it's more about the approach, right? Not necessarily the specific content of the book, but the way it encourages us to, rethink what we thought we knew.
Exactly. It's like just as the book challenges these accepted scientific models, these ideas about planet formation that we kind of take for granted, creationists often position themselves as offering a different lens, right? They're saying, hey, here's a different way of looking at things, a different explanation for how things came to be.
So it's like we have this other explanation, and it might line up more neatly with, say, a specific interpretation of these religious texts. But the book isn't saying that, right? It's still working within, the framework of science, right? Yeah. Just pushing those boundaries a little.
Yeah, and that's a key difference there, right? The book, it might be pushing us to re-examine our assumptions, to consider new evidence, new interpretations, but it never actually abandons the scientific method. It's still grounded in that process of observation, experimentation, testing, revising, which is not always the case in these, creationism versus evolution debates, right?
Right. It's like choosing your set of tools. You can use scientific observation, experimentation, all that good stuff. Or you can rely on interpretations of, religious texts. And those are two very different paths, even if they're trying to answer some of the same big questions.
And, those interpretations, they can vary so much, even within the same religion. Remember we were talking about at the end of the last part how there are all these different views on creation, even within different religions? Well, that's something that the Wikipedia article actually gets into a bit, and I think it's a really fascinating angle to this whole thing.
I'm so glad you brought that up because, yeah, it's easy to get caught up in this back and forth between science and, certain interpretations of religious texts. But we have to remember that it's not just two sides shouting at each other. There's a whole spectrum of beliefs out there. So, what are some of those different views within religions? What are we talking about there?
Well, take Islamic creationism, for example. The Wikipedia article talks about how while Muslims generally believe that God is the creator, right, there are a bunch of different interpretations about how that creation actually went down.
Okay, so there's room for different interpretations even within one religion.
Totally. You've got some folks who interpret the Quran as saying that creation literally happened in 6 days, like it says. But then you've got others who see it more metaphorically, who say, no, these 6 days could represent vast periods of time, billions of years even.
Wow. Okay, so even within one religion, you have interpretations that might align more closely with the scientific timeline of the universe and others that stick to a more literal reading of the religious text.
Exactly. And this whole idea, this diversity of thought within religions, it's not just an Islam thing. Like Hindu cosmology, they have this whole other perspective on the universe, how it began, what it all means. They've got this idea of cyclical creation and destruction where the universe goes through these endless cycles of being born, expanding, collapsing, and then starting all over again. Whoa, okay, that's a completely different way of thinking about it than the Western idea of a single creation event.
Right, and I think it's a good reminder that these discussions, they're complicated. There's so much nuance with different perspectives overlapping and, disagreeing and coming together in all these different ways. It's a good reminder to, stay humble, to approach these conversations with curiosity and a lot of respect for the fact that there are so many different ways of looking at these things. Okay, so we've covered the scientific method, the role of interpretation, and now this idea that even within what we might call religious viewpoints, there's a ton of diversity. But like, what does all this mean for, someone listening to this right now? How do they make sense of this whole debate, this whole landscape?
That is the question, right?
Yeah.
And it's one I get asked a lot. And honestly, I think the biggest takeaway is this. If you really want to understand this whole creationism versus evolution thing, you got to be willing to go beyond the surface level. You got to be willing to recognize that there are these deeply held beliefs on all sides of this, beliefs that are rooted in people's faith, their philosophy, their interpretation of the evidence.
So it's less about trying to win the argument and more about understanding where everyone's coming from.
Yes, 1,000 times yes. Because when you approach this debate with that kind of openness, that willingness to really listen and learn and acknowledge how complex it all is, that's when you can start to have a meaningful conversation. And maybe, just maybe, you might even find some common ground in all of that.
That's a nice thought, right? That maybe through all this, through engaging with these really big questions, we might actually find ways to understand each other better, even if we don't always agree. Okay, so we've talked about a lot, but I feel like we've only scratched the surface here. There's so much more to explore.
Oh, absolutely. And I don't know about you, but my brain is definitely ready for a break.
Mine too. We've covered a ton of ground here, from the philosophical foundations of this whole debate to the mind-blowing vastness of space and all the different ways we try to wrap our heads around it all. But don't worry, we're not done yet. We've got one more part to this deep dive, so stick around. We'll be right back after a quick break.
All right, so break time's over. Brains are hopefully rebooted. You were about to blow my mind with some resources, some ways to keep diving into all this. Lay it on me. Where should we go from here?
Okay, so if you're more into like the hard science side of things, I'd say check out some of the amazing stuff that universities and scientific organizations are putting out there.
Like where? Give me some specifics.
Oh man, there's so much. National Geographic, for one. Their photography alone is mind-blowing.
Oh, yeah. I could get lost in their photos for
Yeah.
hours. Right. But they also have fantastic, like, articles, videos, even podcasts on evolution, the natural world, all sorts of cool stuff.
Okay, so National Geographic, what else?
Scientific American's another good one. And then you've got organizations like the National Academy of Sciences. They've got a ton of resources that dig into the evidence for evolution, the complexities of how nature actually works, all based on, actual research.
Okay, so we're talking like reputable sources, the real deal, which is good because there's a lot of, shall we say, less than reliable info out there too.
Oh, tell me about it. That's why it's so important to, like you said, stick with the sources you can trust. And hey, don't underestimate the power of a good old-fashioned book either.
You know what? That's true. Sometimes you just need to sit down with a beautifully crafted book, really get into it. It's different than scrolling through articles online.
Totally. Like National Geographic, again, their books on evolution, the natural world, those are stunning. Oh. Beautiful photos and packed with information.
Okay, sold. Adding those to my reading list. Yeah. But what about the, bigger questions? We talked about philosophy, theology. Where do people even begin to explore those aspects of this whole thing?
Yeah, that's where things get really interesting, right? Because it's not just about the science itself, but about what it means for us, for our understanding of, well, everything.
Exactly. So where do we find those deeper dives?
Well, luckily, there are tons of amazing thinkers out there, theologians, philosophers, ethicists, writing and speaking on just these kinds of questions. And they're coming from all sorts of different backgrounds, different faith traditions, which I think is really cool. It's not just one monolithic viewpoint,
No. So it's a conversation happening across disciplines, across different belief systems.
Exactly. And it makes for some really thought-provoking stuff. Like, you might be interested in the work of theologians who are specifically trying to reconcile their faith with, what we know about evolution. They're wrestling with some really big questions about, like, if evolution is real, where does that leave the role of a creator? How do those two things fit together?
Man, yeah. That's something I could think about all day.
Right. Because it's not about having to choose one or the other, It's about trying to hold both of those things, scientific understanding and religious belief, in a way that feels, true to you.
That's what makes this whole conversation so much bigger than just science versus religion, right? It's about how we make sense of the world, how we understand our place in it.
100%. And honestly, that's what I find so exciting about all of this. Right. The more we learn, the more we realize how much we don't know. It's like this amazing ongoing journey of discovery.
Totally. And this deep dive, it's just the beginning, right? It's like we've given our listeners a taste, and now it's their turn to go out there and explore.
Yeah. Pick a thread, see where it leads, read a book, listen to a podcast, start a conversation with someone who sees things differently than you do. You never know what you might discover.
I love that. That's what we're all about here at the Deep Dive, right? Giving you the tools, the inspiration, and then setting you loose to explore this amazing universe of ideas, because that's how we grow, how we learn, how we become more, well, human. So yeah, on that note, we're going to wrap up this incredible deep dive into the creationism versus evolution debate. Hopefully you're walking away from this with more questions than you started with.
And the desire to go out and find those answers for yourself.
Yes, keep those minds open, keep those questions coming, keep those conversations going. All right, so you want to tackle the Big Bang, huh?
Sounds like someone's been doing their cosmic homework.
We're looking at scientific papers, creationist critiques, even a little peek into the search for exoplanets. You're really going for the deep dive here.
It's a fascinating mix. You're grappling with the biggest question out there. How did this all begin?
And are we alone in the universe? Because we've got that in the mix, too. What I find interesting is the tension, right? We've got the Big Bang, this idea that the universe exploded into being.
Universe from nothing.
Well,
mind-boggling.
But then we've got these creationist viewpoints that offer a totally different perspective.
The age-old debate. And one that still sparks debate and discussion even today.
Exactly. And by the end of this deep dive, you'll not only understand these different viewpoints, but you'll be able to hold your own in a conversation about them.
We'll equip you to impress even the most, shall we say, enthusiastic science buff at your next cocktail party.
Ha ha! Love it. Okay, so let's do this. Big Bang, take us back to the very beginning, set the scene. What did the universe even look like back then?
Okay, so picture this. A universe smaller than an atom. Unimaginably dense. Unimaginably hot.
Not exactly a place you'd want to hang out.
Exactly. Definitely not hospitable. And then from this tiny point, expansion. Rapid expansion. But think less of an explosion, more like a balloon inflating at an incredible rate.
Okay, so less of a bang and more of a rapid stretching.
Exactly.
What happens as this expansion unfolds? What's cooking in this rapidly expanding universe?
Well, in those first fractions of a second, we're talking chaos. A chaotic soup of fundamental particles, quarks, electrons, the real building blocks of, well, everything.
The tiniest ingredients imaginable?
Exactly. But as the universe expands, it also cools. And that cooling allows these particles to start combining. Protons, neutrons, they start to form.
So from a subatomic mosh pit to a slightly more organized cosmic dance floor.
That's a great way to put it. And this cooling process, it's crucial because now these protons and neutrons, they can pair up. And that's when we get the first atomic nuclei, primarily hydrogen, with a little bit of helium.
Setting the stage for the universe as we know it. But, I mean, we're talking about things happening on a timescale that's just mind-boggling. Why should we trust this whole Big Bang idea? What's the evidence?
You're right to ask that. We don't just accept things on faith and science. We need evidence. And the evidence for the Big Bang, well, it's pretty compelling. One of the key pieces is the redshift of galaxies.
Redshift. Okay, break that down for me.
Imagine the sound of a siren as an ambulance races away from you. The pitch gets lower, right?
Yeah, because the sound waves are stretching out.
Exactly. Light waves work similarly. As galaxies move away from us, their light stretches, shifting towards the red end of the spectrum.
So the farther a galaxy is from us, the faster it's moving away and the redder its light appears.
You got it. We see this red shift in almost every galaxy we observe. And that tells us that the universe is expanding, just like the Big Bang Theory predicts.
Okay, that makes sense. What other clues point toward this grand event?
Think about it. The Big Bang, this unimaginably hot event. Where did all that heat go? It didn't just vanish. It's still out there, stretched out over billions of years of expansion as faint microwave radiation.
So you're saying we're practically swimming in the afterglow of the Big Bang?
In a way, yes. This cosmic microwave background, or CMB, it's everywhere you look in space. And it's not perfectly uniform either. There are tiny variations in its temperature.
Variations. What do those tell us?
Think of it like looking at ripples on a pond. Even tiny ripples can tell you about the size and shape of the object that created them, right?
Right.
These subtle temperature fluctuations in the CMB, they give us a glimpse into the early universe's structure. They tell us about the seeds of what would eventually become galaxies and galaxy clusters.
We're talking about gleaning information about the universe's infancy from these minute temperature differences.
Exactly. Pretty amazing, isn't it? And there's one more piece of evidence I want to touch on.
Hit me.
The abundance of light elements. Hydrogen, helium. The Big Bang model predicts a very specific ratio of these elements in the universe.
Drumroll.
When we actually measure these elements, the observations match the predictions incredibly well. It's another strong indicator that the Big Bang model is on the right track.
So we've got the redshift of galaxies, we've got the cosmic microwave background, and we've got the abundance of light elements. That's a pretty compelling case for the Big Bang.
It is. But of course, our listener wouldn't have brought us these sources if there weren't other viewpoints to consider.
You're right. They've also included some creationist perspectives in this stack, which present a different take on the universe's origins. And it's important that we explore them.
Absolutely. These viewpoints are quite prevalent and deserve a closer look, even if we might not personally agree with them.
Exactly. We're all about getting the full picture here. Now, from what I understand, there are two main camps within creationism itself, right?
Right. You've got young Earth creationists. They interpret the biblical creation account quite literally, believing the universe is only a few thousand years old.
Which obviously clashes with the billions of years proposed by the Big Bang Theory,
Yeah, a pretty significant difference there.
to say the least.
Hmm.
Then there's the old Earth camp.
Exactly. Old Earth creationists, they might be okay with an older universe.
Mm-hmm.
But they don't necessarily accept evolution by natural processes as the explanation for, well, the diversity of life we see, especially when it comes to the complexity of humans.
So it's not always about the universe's age, but rather the how of it all.
You got it.
Now, I noticed one of the sources, Answers in Genesis, mentions a lack of population third stars as evidence against the Big Bang. Can you unpack that for us? What are those, and why does it matter if they're missing?
Okay, so population 3 stars. These are hypothetical stars. The very first stars thought to have formed after the Big Bang. And they would have been composed almost entirely of hydrogen and helium.
The simplest elements.
Exactly. The most basic building blocks.
So the creationist argument is, if the Big Bang happened, where are these stars? Shouldn't we see them?
That's the gist of it, yeah. But, and here's where the deep dive comes in, the source doesn't really give you the full story. It presents this absence of observed population 3 stars as this big challenge to the Big Bang, but it doesn't address why these stars might be so difficult to find.
It's more of a raised eyebrow than a full-blown explanation.
Exactly. And it's important to remember that these first stars, they were likely incredibly massive, incredibly bright, and they burned through their fuel very quickly.
So kind of like the rock stars of the early universe.
Yeah. They lived fast and died young. And because of that, they're incredibly faint and difficult to observe directly with our current telescopes.
So it's not just a matter of pointing a telescope at a random patch of sky and expecting to see them.
Right. It's more like trying to find a needle in a cosmic haystack, a very faint needle.
Makes sense.
We haven't observed these population 3 stars directly yet, but their existence is still supported by other lines of evidence and our theoretical models.
It's a good reminder that science is a process of ongoing discovery. Absence of evidence isn't always evidence of absence. We learn more, refine our theories, and sometimes we get surprised. Which I think leads us to a pretty big question, maybe the million-dollar question. Can someone accept the scientific explanation of the Big Bang and still hold religious beliefs about creation?
It's a question a lot of people grapple with, especially given the sources our listener has provided.
Right, so how do we reconcile these seemingly disparate views?
Well, one of our sources, a publication from the National Academy of Sciences, addresses this tension head-on. And they argue that science and religion, they operate within different realms of understanding. Science, it deals with the testable explanations of the natural world. It relies on observations, experiments, data. Religion often grapples with questions of meaning, purpose, morality.
So it's not about one being right and the other being wrong. It's more like two different lenses through which to view the universe.
Exactly. Trying to force them into the same box is where things can get messy. The National Academy of Sciences suggests that these two views, they're not inherently incompatible. They can actually complement each other.
Passes.
Well, science can address the how of the universe, right? How it came to be, how it evolved, while religion can offer perspectives on the why of our existence, the purpose behind it all.
I like that. You know, it makes me think the universe is so vast, so mind-bogglingly huge. Maybe there's room for both. It's not like we've uncovered every secret the cosmos holds.
I love that perspective. And ultimately, how any individual reconciles scientific understanding with personal beliefs, it's a deeply personal journey. The wonder of the universe isn't diminished by understanding the science behind it. If anything, I'd argue it enhances that sense of awe.
Absolutely. It's like knowing the intricacies of how a flower blooms, it doesn't make you appreciate its beauty any less, right?
Exactly. It adds a whole other layer of appreciation.
Now, speaking of fascinating possibilities, one of the sources throws a real curveball and mentions an alternative cosmological model called, get ready for this, Darwinian mechanics.
Okay. I see why you said get ready. That's a new one.
Right. So what's that all about?
So this model, it proposes this idea that galaxies, instead of forming from a single point, they actually evolve and multiply through a process of fission. Imagine a massive primordial galaxy breaking apart into smaller galaxies, similar to how cells divide.
So a kind of cosmic reproduction. It's definitely a thought-provoking concept.
It really is.
But does this model hold the same weight as the Big Bang theory?
It's an interesting idea, but I have to be honest, it hasn't quite garnered the same level of scientific support as the Big Bang. The evidence for the Big Bang is currently much stronger.
That makes sense.
But that's the beauty of science, isn't it? Yeah.
Always evolving.
Exactly. It's crucial to stay open to alternative perspectives while also critically evaluating the evidence they present. And who knows, maybe with further research and observations, Darwinian mechanics will gain more traction. Or maybe it will remain an intriguing footnote in the grand story of cosmology.
I love that. So we've got the Big Bang, we've got creationist viewpoints, and we've even touched on alternative models like Darwinian mechanics. Our listener has given us a lot to unpack here, but we're not done yet, are we?
Not even close. They've also included some fascinating information on exoplanets. Remember those?
Ah, yes. Planets orbiting other stars. That's a whole other level of cosmic exploration. And speaking of which, I think it's time we bring our listener back to that initial question, are we alone in the universe, and leave them with something to ponder. So we've got these exoplanets, thousands of them discovered already, right?
And more being discovered all the time. It seems like every time we look up, there's a new planetary system out there just waiting to be explored.
It really puts things into perspective, doesn't it? The sheer scale of the universe.
It's humbling, to say the least.
It makes you wonder, if we were to find life out there, how would that impact our understanding of how it all began? You know, the whole Big Bang, creationism debate, even the alternative models we've been discussing.
That's a big question, and it's one that scientists and philosophers have been wrestling with for a long time.
Because it would kind of shake things up a bit, right?
To say the least. The Big Bang model, as we understand it now, it describes the observable universe, right? The part we can see and study.
Right.
But what if that's just a tiny, tiny piece of a much larger puzzle?
Oh,
Like looking out your window and assuming the entire world looks exactly the same.
we could be just scratching the surface of what's out there.
Exactly. Imagine finding life on an exoplanet with completely different physics or a different origin story altogether.
Life that didn't arise from a Big Bang or follow the same evolutionary path as life on Earth.
Exactly. It would challenge everything we thought we knew about how universes form, how life arises. It would suggest that the rules governing our universe might not be so universal after all.
Mind-blowing. So, are there any theories out there that try to address these mind-boggling possibilities?
There are. And they venture into some pretty wild territory.
Like what?
Well, some theoretical physicists, they're exploring this concept of a multiverse.
A multiverse.
Yeah, it's this idea that our universe, the one we know and love, it's just one of many universes out there. And each universe could have its own set of physical laws and constants.
So there could be a universe where gravity works in reverse, where time flows backward, maybe even a universe where up is down and cats chase dogs.
Uh-huh. You never know. The point is, in a multiverse, anything is possible.
It's like something straight out of science fiction.
It does, doesn't it? But it highlights the limitations of our current understanding. We're still just scratching the surface of what's out there.
In the multiverse, that's still very much a theoretical concept.
It is, but it's a testament to how much we still don't know and how much is left to discover. This deep dive has taken us from the first moments of the Big Bang to the mind-bending possibility of multiple universes.
From the tiniest particles to the most profound questions about our place in the cosmos. It makes you realize, doesn't it, we're part of something much bigger than ourselves.
We are. And that sense of wonder, of curiosity, that's what drives us to keep exploring, to keep asking questions.
Exactly. So to our listener out there, we say this, never stop questioning, never stop exploring. The universe, or perhaps the multiverse, is full of mysteries just waiting to be unraveled. Keep those minds curious. And as always, we've got links to all those fascinating sources mentioned in this deep dive over in our show notes. All right, strap yourselves in because this deep dive is going to take us right to the edge of what we think we know about, well, everything.
Sounds exciting.
Oh, it is. We're talking about the origins of the universe, but with a twist, naturally. We've got two sources for this deep dive, and let me tell you, they couldn't be more different.
Oh.
One is diving deep, no pun intended, into this model of the universe that basically says, Einstein, you're great and all, but Newton's calling the shots on this one. And the other, it's exploring the idea that the Big Bang might actually back up a faith-based perspective.
Wow, talk about contrasting viewpoints. To fully grasp that first model, though, it might help to quickly revisit the Big Bang Theory, just so we're all on the same page.
Right, because the Big Bang is kind of the reigning champ in the world of cosmology, isn't it?
Exactly. The idea is that the universe as we know it burst forth from an insanely hot, dense state, roughly 13.8 billion years ago. And we found clues that support this theory, like the fact that the universe is expanding.
And don't forget about that faint afterglow, the cosmic background radiation they always talk about. So where does this other model fit in? It sounds like it goes against the grain.
It does. Think of it this way. What if, instead of one colossal explosion, the universe is constantly changing and evolving through a totally different process?
Okay, you've piqued my curiosity. How could the universe form without a Big Bang? What's the alternative?
Imagine if galaxies weren't formed from collapsing gas clouds, as the Big Bang suggests. What if instead they were created through this ongoing process of, well, fragmentation?
Fragmentation, so more like a big breakup instead of a Big Bang.
Precisely. Picture these ancient, massive structures, real giants of the universe breaking apart. Those pieces then scatter and become the galaxies we know and love today.
That's a pretty big departure from the collapsing gas cloud idea. Are you saying these giant structures are just breaking apart and forming, well, everything? Stars, planets, the whole cosmic shebang?
Exactly. And this fragmentation thing goes even further. It explains how planets and moons come to be, too. It's like when you see a spinning droplet of water start to fling off smaller droplets as it spins faster.
Wait a minute, I'm trying to visualize this. So you're suggesting that Earth was once part of something much bigger, something spinning so fast that it just flung us out into space.
Now you're getting it. And get this, the source even compares the motion of our solar system, all the planets orbiting the sun, to a group of figure skaters doing a perfectly synchronized spinning jump.
Okay, I have to admit, that's a pretty cool way to picture it. Each planet spinning and holding its own as it orbits the sun. But maybe this is a silly question. What about those gorgeous spiral galaxies we always see in pictures? How do they fit into this whole fragmentation model?
That's where Edwin Hubble's tuning fork model comes into play. Think of an actual tuning fork, the two-pronged thing. Those elliptical galaxies, the oldest ones in the universe, they're like the base of the fork. And as they vibrate, they kind of shake off material and energy. And bam, over a really, really long time, they morph into those stunning spiral galaxies like our own Milky Way.
So the universe isn't this static, unchanging picture at all. It's constantly moving, changing, reshaping itself through this fragmentation and expulsion process. I don't know about you, but I find that incredibly mind-blowing.
Mind-blowing is a good way to put it. It definitely forces us to reconsider what we thought we knew about how planets, stars, and even entire galaxies are formed.
It makes you wonder, what else might we have gotten wrong?
Exactly. And speaking of getting things wrong, this model has a very different explanation for how moons and planetary rings are formed.
You mean like how our own moon came to be? Tell me more.
Okay, so picture this. Earth, but not as we know it. Instead, we have this superheated proto-Earth spinning incredibly fast. At a certain point, the centrifugal force becomes so powerful that a piece of the Earth basically breaks away.
Talk about a cosmic breakup. So you're saying that instead of some massive object crashing into Earth and creating the moon, it's more like our moon is a long-lost sibling that got flung out into space.
In a nutshell, yes. And the same principle applies to those amazing rings around Saturn and other planets. It's just molten material being flung outwards and either escaping the planet's pull completely or getting stuck in orbit, creating those breathtaking rings.
That makes a lot of sense, actually. But what about the giant impact theory? The idea that a Mars-sized object slammed into Earth and the debris formed the moon? That's what I've always heard.
Right, and it's the prevailing theory. But this source makes a compelling case that this fragmentation model might better explain the physics involved. It's all about looking at the nitty-gritty mechanics.
So The takeaway here is that the universe isn't afraid of a little shakeup every now and then, right? But it goes even deeper than exploding stars and flung off planets, doesn't it?
It does. It goes so deep, in fact, that we need to talk about something called deep Earth anaerobic biosynthesis.
Okay, before we dive into that, remind me, what's the generally accepted theory about the origin of life?
Right, so the usual suspects are comets carrying those essential building blocks of life, or those superheated vents we find on the ocean floor.
But this source, it takes us on a journey to the center of the Earth.
In a way, yes. Deep Earth anaerobic biosynthesis, you're right, it's a mouthful.
It is, but it sounds intense. Like, what are we talking about here? Life forming in volcanoes?
Not quite volcanoes, but close. It's about life forming, not in those primordial soups we always hear about, but miles below the Earth's surface.
So instead of on the surface, like at the bottom of the ocean or in some warm pond, we're talking about life emerging from the Earth's core.
Not quite the core itself, but deep within the Earth's crust. This model says that life thrives on the intense pressure and heat found way down there, fueled by the Earth's internal furnace.
Okay, we've gone from cosmic billiards to subterranean life in just a few minutes, and honestly, I am here for it. Keep going.
Picture a hidden biosphere, teeming with life, fueled by the planet's internal furnace instead of the sun.
Wow, a hidden biosphere. The image of the subterranean world thriving in the intense heat and pressure beneath our feet is fascinating, but also a little creepy, if I'm being honest.
Yeah, it makes you wonder, what are those extreme conditions and would any planet do? Or does life need a specific cosmic recipe to get started?
Right, like, could life as we know it exist on any planet?
That's the heart of this model. It suggests that only planets capable of certain types of nuclear reactions in their cores, things like beta decay, positron decay, even nuclear knockout reactions. Only those planets would have what it takes for life to begin.
So, not just any planet then. It needs the right internal engine, and maybe that means planets like ours, planets that can support life, are even more rare and special than we thought.
Exactly. And what makes this idea even more interesting is that there's some evidence to back it up. The source mentions the Kola superdeep borehole.
Oh, yeah. Wasn't that a massive hole drilled by, I think it was Russian scientists back in the 70s? Didn't they have to stop because it just got too hot, like literally melting their equipment?
That's the one. But here's what's fascinating. Before they had to stop, at a depth of around 4 miles, they found microscopic fossilized plankton.
Plankton, as in the tiny organisms that live in the ocean. 4 miles underground. How's that even possible?
It does seem counterintuitive, right? And it challenges our assumptions about where we might find evidence of life. But, get this, it gets even weirder. They also found gases down there that weren't supposed to be there, things like hydrogen and helium.
Gases that, if we understand how Earth was formed, should have been gone billions of years ago. Are you saying these plankton were just hanging out down there, miles beneath the surface in the pitch black?
It's a real possibility. This finding could point to a massive, undiscovered biosphere hidden deep within our planet, thriving in conditions we thought were impossible for life. And it gets even more interesting when you connect this to the Urey Miller experiment. You know, the one.
The one from the 50s, where they recreated the conditions of early Earth's atmosphere?
That's it. They ended up creating amino acids, the building blocks of proteins. But the source argues that while the Urey Miller experiment was a big deal, it might have been too simplistic. It didn't consider the potential role of Earth's internal heat and pressure, or all the chemical reactions happening deep underground.
So instead of life emerging from a test tube, it's more like a pressure cooker, fueled by the Earth itself.
Exactly. It's like both the Urey Miller experiment and this new model are looking for the recipe for life, but they're looking in different kitchens.
That's a great analogy. So this model suggests that life on Earth could have emerged from these deep subterranean environments. Does that mean we could find life hidden beneath the surface of other planets, too? What about places like Mars, or those icy moons orbiting Jupiter and Saturn?
It's a tantalizing possibility, isn't it? Maybe life doesn't need sunlight after all. Maybe all it needs is the warmth and energy of a planet's inner fire. But before we get too caught up in the wonders of deep Earth biosynthesis, we have that other source to consider. Remember, the one that looks at the Big Bang Theory from a faith-based perspective.
Right. That should be interesting. This source tackles the biggest question of all. Why is there something rather than nothing?
Exactly. And I think it's important to approach this source with an open mind, ready to explore some really big ideas.
I'm all for open minds and big ideas. So tell me, what's the connection between the Big Bang and a belief in a creator?
Well, this source was written by a Christian physicist who dives into this idea of fine-tuning in the universe. It makes you wonder, why does the universe seem so perfectly calibrated for life for us to even be here?
It's true, even someone like me who's no expert in physics, you look up at the night sky and think, how is it all so perfectly balanced? The laws of physics, the fundamental forces, even the value of those constants, it all just works.
Exactly. That's precisely what the source is getting at. Even the tiniest change in those fundamental constants, poof, stars wouldn't form, planets wouldn't exist, life as we know it would be impossible.
So it's not just about having the right ingredients, it's about having them in the exact right amounts.
Yeah.
Like baking a cake, you can't just throw things in a bowl and hope for the best.
And that's the crux of the fine-tuning argument. The odds of a universe like ours, with its life-permitting parameters, coming into being purely by chance, astronomically small, this incredible improbability, the source argues, points towards a designer, a force outside of the universe that set everything in motion.
So, the Big Bang, instead of contradicting the idea of a creator, actually provides evidence to support it. That's a pretty bold claim.
It is bold, and it's a perspective worth considering. The source suggests that the universe itself, its fine-tuned laws and constants, could be seen as evidence of a creative force at work.
So even with seemingly opposing views, there can be unexpected connections and common ground. Who would have thought that the Big Bang Theory and the Bible might have something to say to each other?
It really highlights that. While science is amazing at explaining how things work, the mechanics, the process, the evolution, it often struggles with the why. That's where philosophy and religion often step in, offering interpretations, meanings, and frameworks for understanding where we fit into the grand scheme of things.
So we're left with two very different yet captivating models of the universe. One where cosmic evolution is a constant dance of fragmentation and rebirth. The other where the universe's very existence points towards intelligent design. Two sides of the same coin, maybe?
Maybe. But how do we reconcile these seemingly contradictory ideas? How do we make sense of a universe that seems inherently chaotic, yet incredibly ordered at the same time? Where does that leave us?
That's the million-dollar question and the perfect cliffhanger for our listeners to ponder. It really is a mind bender, isn't it? On this deep dive alone, we've gone from exploding stars to the possibility of life in the Earth's crust, and now we're grappling with the biggest questions of creation and design.
It's a lot to process, that's for sure. We have these two models of the universe, each offering a completely different perspective.
On one hand, we have this universe where everything's in constant motion. Stars are born, planets are flung into existence, galaxies take shape, all through this incredible, almost chaotic process of fragmentation.
A universe that's constantly reinventing itself.
Exactly. And it really challenges us to rethink everything we thought we knew, right?
It does. Because then we have this other model, the finely tuned universe, where the laws of physics are so precise, so perfectly calibrated, that even the smallest change would mean no stars, no planets, no us.
Talk about a mind-blowing concept. If the universe is constantly breaking apart and reforming, how can it also be so carefully designed? It doesn't seem to make sense.
It's a paradox, for sure. And maybe that means we're still missing a big piece of the puzzle.
Right. We think we know so much about how the universe works, and then something like this comes along and throws everything we thought we knew out the window.
Like trying to understand the ocean by looking at a single drop of water.
What if, instead of looking at these two models as contradictory, we consider the possibility that they're both correct? That the universe isn't black or white, either or, but both.
You're talking about a universe that embraces both chaos and order, that can be spontaneous and intricately designed.
Maybe what we see as randomness, as pure chance, is simply a reflection of how much we still don't know about the universe and how it works.
That's what makes these deep dives so fascinating. We don't have all the answers. We just keep asking questions, keep exploring, keep searching for those missing pieces.
Exactly. So to our listeners out there, we leave you with this. What if the universe doesn't fit into our neat little boxes of order and chaos? What if the very act of searching for answers, for meaning, for understanding, is what propels us forward on this incredible journey of discovery?
We may never have all the answers, but in the pursuit of those answers, in the act of questioning and exploring, we unlock something truly remarkable. A deeper appreciation for the vastness and wonder of the universe we call home.
That's a beautiful thought to end on. Thanks for joining us on this incredible journey into the heart of the cosmos. Keep looking up, keep questioning, and we'll catch you next time for another deep dive.